In this video, we are going to be putting it all together here, solving one-step inequalities with rational numbers. So our essential question is, how do you solve one-step inequalities with rational numbers? So how do we solve these one-step inequalities? Now we're going to put all four operations together and be including our decimals and fractions. The strategy still remains the same, though. We're going to undo the operation using properties of inequalities, but we still have to remember those two special cases. Whenever we multiply or divide by a negative number, we have to remember to flip that inequality symbol whenever those happen, okay? So make sure that we're paying attention to what we're doing to both sides of the inequality when we solve it. If we are multiplying or dividing by a negative, then we are going to have to flip that inequality symbol. So some examples here, solve these inequalities. Here I have a subtraction problem, so I don't really have to worry about flipping the inequality at all because there's no multiplication or division in this problem at all. So I can just take that off the table right away. I'm going to undo the subtraction here by adding 9 to both sides of this inequality, and 1.3 plus 9 gives me 10.3, and then h minus 9 plus 9 is just h, and then again my inequality symbol is not going to flip, so this is greater than, h is greater than 10.3. And then as always, I'm going to show my solution on a number line because there's more than one possible answer here. So here's my 10.3, 10.4, 10.5, a couple values to the left, 10.2, 10.1, and since h is greater than 10.3 and 10.3 is not included, that's an open circle, and it's everything to the right, everything greater than 10.3. Next one, we have -3/4 is less than or equal to w minus 1/4. We haven't seen a whole lot of problems like this one actually, where the variable is on the right-hand side of our inequality. So we'll see how we handle that here when we come to the end. Still going to look here and see what operation I have to undo. And this is subtraction. So I'm going to add 1/4 to both sides of this inequality. So I have -3/4 plus 1/4. And -3/4 plus 1/4 is -2/4, which is -1/2 in simplest form. And again, I was adding to both sides, so I don't have to think about flipping this inequality. It's going to stay less than or equal to. And then on the right-hand side, I just have w. Now, sometimes seventh graders struggle with this when it's written, I guess, quote unquote, backwards with the variable on the right-hand side. So -1/2 is less than or equal to w. Well, another way we could think about that is, or w is greater than or equal to -1/2. These mean the same thing. So if you're more comfortable with that variable on the left-hand side, you can go ahead and turn the whole thing around and kind of make it a mirror image of what it was. If the one on the right is a little easier for you to interpret. Either way, the graph will look like this. Here we have -1/2. This would be 0. This would be -1. So w is greater than or equal to -1/2. So -1/2 is included. That's a filled in circle, and it would be everything to the right. So no matter which one of these inequalities you're thinking of, this would be the graph for it. So -1/2 is our cutoff, and it's everything greater than or equal to -1/2. Couple more. 4/5 t is greater than -8. So here now we have multiplication going on. So I'm going to have to divide. So now I'm going to have to be aware of what I'm dividing by when I decide whether to keep or flip my inequality symbol. I'm going to divide both sides by 4/5. So that's what I'll show here. -8 divided by 4/5. And 4/5 t divided by 4/5 is just t. And -8 divided by 4/5 is -10. And now I have to make a decision because I did divide both sides by a number. Am I going to keep or am I going to flip? What do you think? Well, I divided both sides by a positive number, so I'm going to keep. T is greater than -10. So again, if I graph that, here's -10, -9, -8, -11, -12, and t is greater than -10. So -10 is not included. That's an open circle. And everything that is greater than -10, I would be shaded to the right. So I did not flip on that one. That was a keep. And then lastly, g divided by -1.2 is greater than or equal to 7. So I have to undo the division. So I'm going to multiply. I'm going to multiply both sides by negative 1.2. Hopefully there's something going off on your radar right now that says, uh-oh, I'm multiplying both sides of this inequality by a negative number. So g divided by negative 1.2 times negative 1.2 is just g. 7 times negative 1.2 is negative 8.4. Now the decision, should I keep or should I flip? Because I did multiply both sides of this inequality by a number and it was negative. So what does that tell us? We need to flip. So I'm going to flip this inequality around. That is going to be less than or equal to. So g is less than or equal to negative 8.4. That's my solution. So when I go to graph that, put my negative 8.4 in the middle here. Here would be negative 8.3, negative 8.2, negative 8.5, negative 8.6. And it is less than or equal to, so this is included. Negative 8.4 is a solution, and it's everything that is less than or equal to negative 8.4. So that would be shaded to the left. And there's the graph there. And that is solving our one-step inequalities with rational numbers. You can see we do the same stuff, just now we have fractions and decimals involved, positives and negatives. And as always, remember to pay attention to what you're multiplying and dividing by. If that's a negative number, you have to flip that inequality symbol around.